let's start with implementing the logistic regression using Python. I'm going to take a simple data set which is around the Australian weather, and we are here to classify these records into ones and zeros. Now, one meaning that it is going to rain tomorrow, and zero meaning it is not going to rain tomorrow. So our target column is rain tomorrow. So this is a supervised learning technique, and we are going to use logistic regression for classifying all these records into zero and one. To start off with, let us see what all we have. Like we we have many different columns, like the location, what is the minimum temperature of that particular location, and maximum temperature. If there is a rainfall, what is a measure of rainfall, and some other attributes like evaporation, sunshine, the speed of the wind, the direction of the wind, and the humidity, pressure, and many other features. Okay, we are going to use all this to classify the data, whether it is going to rain tomorrow or it is not going to rain tomorrow. So let me go back to my Python code. You can find my code in Git. So this is my Git. I think I already shared with you, but just in case if you want to take a look at it one more time, this will be my Git URL. Let me mark it down. Okay, let's begin the session. I'm going to import some necessary libraries, something around pre-processing by using sklearn pipeline, and then we have some pandas for reading the data frame, matplotlib and cpon for plotting the graphs, which is necessary. And then we have something called as column transformation. This will be used for pre-processing steps again, and one hot encoder as well as standard encoder for handling your continuous values and categorical values. And last but not the least, we have the metrics evaluation library. Okay. This is one single import cell. We are going to import all the necessary libraries in one go. Okay. Now, what I'm going to do is I'm going to take both the train dataset as well as a test dataset. I want to show you how to apply the same pre-processing steps on both the datasets by writing the code properly. Okay. Uh, if you want to just have a look at the records, this is how the dataset looks like. Rain tomorrow is our target column with just zeros and ones. Similarly, in the test data, we don't have the target column here. So you don't see rain tomorrow column. Followed by describe all, just shows you how many different values that we have on a given column and what is the range like, how many missing values are there, and so on. We can also look at we can also look at, say, for example, in our target column, how many zeros are there and how many ones are there. So as you notice that, we have 77% of class 0 and 23% odd for class 1. Now what we are going to do is we are going to use this data for training purpose, and then we'll try to find the best model, and we'll use that model for making predictions on our unseen data, which is nothing but the trace data. Let us start with the pre-processing steps. This is I think, if you already know pandas, I think this would be very easy to understand, but let us see what we have. To start with, I'm going to delete off the columns which I'm not going to require. Say, for example, if you notice row 1, ID, this is one, wherein you have row ID, all these are independent identifiers. And these are just identifiers for the record, okay? And we don't need these identifiers for training and evaluation purpose. Similarly, for train tested data set also, you have the same set of records. So what I'll do is I'll try to remove them because we don't require it. I'll drop them off in both the data frames. And then first let us see how many null values are present. So all the columns have decent number of null values. So say, for example, in evaporation, sunshine, like close to 40%, we have nulls. Similarly, for cloud, 9 AM and 3 PM also we have close to 40% of nulls. Same way, I think even in the test data, you would be having nulls. So what we would be doing is we will try to figure out a way to replace all the nulls. Okay, one easy way maybe if find out if the column is categorical. If the column is categorical, replace it with the mode, and if the column is continuous, look at the distribution and try to replace it with the median. Okay, so instead of doing that, I want to do it in a different way. What I'll do is I'll take one column now, called rain today, and looking at rain today, I can see that now close to 76% is no, and 22% is yes. So I'm going to replace all the null values with no. I think we was supposed to see the rain tomorrow column also. Value underscore counts. We don't have any. Yeah, it is almost same, like 77% and 23%. That's fine. So let us do one thing. Now I replace the nulls in rain today. I replace with it no. So wherever I find a null value in this particular column, I'm replacing with it no. Now let us take the next column, which is minimum temperature. Minimum temperature looks to be kind of uniform. The mean and the median are almost coincident, which is also evident in the describe. So the mean is around 12.17 and the median is around 12.12. So they're almost same. So if you want to replace, you can replace with median value. That's totally fine. But what we want to do is like, because Australia is pretty wide and one state may have different characteristics than the other. Say for example, in India we have North India and South India, right? In Northern India, like in states like Jammu Kashmir, probably the temperatures are far less as compared to states like Kerala and Tamil Nadu. So I cannot calculate a median for complete India and then apply it to Jammu Kashmir or Kerala. Rather than that, what I'll try to do is I'll try to find the median of Jammu Kashmir, apply it only on Jammu Kashmir. I'll try to find a median of Kerala and apply it only on Kerala. Okay, so we're trying to localize the medians and do the imputation. So similarly, we'll do the same thing for minimum temperature. We'll try to calculate the median by doing a group aggregate. And as you can notice, we have Adelaide at 12.7, 10.8, and so on. So what I'll do is like wherever I have a null value, I'm going to find which location it is. Based on whether it rained or not rained, I'm going to impute the respective median values. Say if the column says, sorry, if the record says it rained, I'm going to use this 10.8 for all the records which has location of Adelaide. Okay, I think you can go through this code. I don't want to go at a deeper level. I'm simply calculating the median. I'm storing it in location minimum, and this location minimum I'm trying to use it for imputation. Okay, this is for your train. Now in the case of test, what we're going to do is I'm going to make one more data frame from the train. I'm going to capture my location. I'm going to capture whether it rained or did not rain, and then I'm going to capture what is my median value. This data frame, I'm going to do a left join on my test data set, and then I'll do the same imputation of what I did on the train. So what we're trying to do from the population of a given location, we are finding the median and we are applying in on our test data set. But we are applying only if the value is null. I don't want to replace other values, right? It makes no sense. We should not be changing the other values. Only for the null values, we're trying to do that. And then if I look at the null values, I don't have any null values because I have imprinted it correctly. Okay. Now let us do one thing. Now we'll do the same thing for max temperature. Again, we are calculating the median and we are inputting it to both the train and test. That is how it is. Okay, we are done with minimum temperature and maximum temperature. Let us go and do with rainfall. Now, rainfall is a measure of how much rain, how much in reality did it rain. Say when somebody says it rained yesterday, so you can go and see the weather reports. Maybe we trained for 5 mm or 1 centimeter or 10 centimeters and so on. So in order to get that, we have this. So wherever you have rain as yes, all of them are no. Going to take yeah. So wherever you see that it rained, there is a non-zero value. If it rained, there's a non-zero value. If it rained, there's a non-zero value. In some cases, maybe no also has 0.2, but the value is too less. Okay? So we are bothered about this, the regions where it rained and what is the measure of the rain. So I'm going to use the same intuition. If there is a null value that is present in rainfall, and in that particular record, the rain today says no, then I'm going to use 0 as my rainfall. But if the record of rain today says yes, and then what I'll do is I'll try to find the median for this particular yes for a given location, and then I'm going to impute it. So for that, the code is simple. Say for yes, for complete Australia, I'm going to get the average rainfall as 5.2, or the median of the rainfall is 5.2. Then I'm going to just simply use this 5.2 for replacing all the values, the null values in rain. There are so many outliers. You need not worry about that for now. As I said, like wherever it is no, I'm going to put 0. Wherever if it is yes, I'm going to put 5.2. And that is the code for that. No? And now let us see what is the output. Now there are no null values in rainfall. Whatever we just did, right, for rainfall, I'm going to repeat the same activity for all other columns. We have, say, for example, if I want to do for evaporation, you see the evaporation metrics at Canberra is little different from the Sale region. So we have to go via location only. It should not be at the complete country level, not at, no, we have to go at the individual location level. So in order to do that, I'm going to use again pandas group by, find out the location minimum, and in few cases maybe you don't have any record for that, so you cannot impute the median, you cannot calculate the median. In that case, I'm going to apply the country median. So what I mean to say is that, say we have a couple of records. Let me annotate it so that will be easy. Say for example, I have location A and the rainfall is no, and the measure of rainfall was 3. I have one more record A, no, sorry, this should be 0.2 maybe, 0.1 A, and here you have a null value. So what I'm trying to do is, for this particular region, for which is not having any rain, I'm going to calculate the median. I have 0.2, 0.1, like this, many different values, right? So whatever is the median of these values, I'm going to put it in this null value. Given a case where a region does not have any recordings, then what will happen? The median will be null. So in these cases, what you'll have to do, because I could not find it the region location level, I'm going to apply it at a country level. I'll find out the median for complete Australia when there was a rain, and then find the median. Then I can apply it for this particular place. Okay, I'm just trying to generalize the imputation so that we can have the model to look at all the patterns that is available. Okay. So in order to do that, I think we have this code. We are going to calculate at the train data level, and then we'll find out. Sorry, I have to run this. Yeah. So we have to first find out the region. So for example, what is the median of a given location? Then, as I said, that median C, we have like close to 30,000 of null values. So which is not expected. But then what we'll try to do is we'll try to do a group by at rain today. I'm not considering the location, and then finding the median. Now this median will be imported to temp evaporation, and then from temp evaporation, I'm going to import it to our actual evaporation column. I'm imputing it just through the actual evaporation column. Whatever we just did, right? I'm going to apply it for all other columns. Even for test data set, I'm going to use a median from the population. And all the steps that are there above, I converted that as a function, impute nulls. I'm doing a group by on first on 2 columns, followed by 1 column, calculating the median. I'm preparing one temp call which is going to capture the actual medians without any null values, and this temp call will be used to impute the null call values and replace all the null values. Okay, so we'll simultaneously do the test data set also. So you can just go through this code just in case if you want to. You can execute this code always and find out what we're doing. All the steps that we did, I just converted them as a function. Also, we have written one more function to calculate the mode of a given series. Say, for example, this is one pandas column. What I'll do is I'll simply find what is the mode, and I'll take the first most frequent value and I'll return it. Okay. Say, for example, I take one categorical column, wind gust direction. If I go and find out what is the mode of this particular data, it says west. Okay, and it will always be west. No matter how many times I execute it, will always be west because that is a mode. Now what I'll do is I'll take 3 categorical columns. I'm going to replace all the null values with respective mode value of a given location. Okay, it replaced and I don't find any null values after replacement. Similarly for continuous columns, I'm going to do the same thing. It replaced. So all the activity we just did, we tried to automate by using function. Now we are done with pre-processing steps, which are to deal with removal of our null values. Of course, we can still apply further processings like remove the outliers, cap them, and see if you can create some new features or not. But for now, for this data set, it is not required. So let us go ahead and convert the respective data types to, we will have to convert the text columns to 100 encoding, and we will have to scale the continuous features. So if you look at each categorical column, we have some distinct values. Like similarly in the test data set also, you have some distinct values. And these are the num calls. Okay, all these columns are continuous columns. Now what we'll do is we'll try to apply pre-processing steps using pipeline. What we will be doing in pipeline is we'll try to create the steps. So for example, first we'll create a numeric pipeline which is going to handle all the continuous features. So what we'll do in this continuous features is we'll apply standard scalar. How we'll say that, you'll simply use pipeline function and pass the steps. In the steps, you'll pass one more function which is nothing but a standard scalar. I'm going to call it. So this will be my numeric transformer. I'm going to use this numeric transformer for converting all the continuous columns to scaled columns. Let me take 80% of the data into xtrain and the balance into xval. We are going to stratify. When I mean stratify, it means that we saw that the data set is not completely having 50% of the records. 77% belong to class 0 and 23 belongs to class 1. So what we'll do is we'll try to maintain the same sort of ratio in our train and validation also. And of course, we are going to do some randomization. And once you have the train, you can directly make use of this pipeline that we declared. How we'll make use of this pipeline is you can do a fit underscore transform on your train dataset and then do a transform on validation dataset and test dataset, just in case if we want to do it. But let us not use pipeline like this. We'll use pipeline also for our categorical columns. So just in case if we want to go via this route, this is also possible. And then what we'll do is we'll try to create one more pipeline for categorical columns. What I'm going to do is I'm going to apply one hot encoding for a given set columns. So first I'll create a transformer and then I will call one column transformer, which is going to combine both my categorical as well as numerical transformers and apply those on respective columns. So I'm going to pass which columns I want to apply. Once I have that, sorry, I do not execute one of the step. Yeah, once I have that, then I can complete the pre-processing stage. And at last, I'm going to add one more pipeline for logistic regression. Okay, I have a pipeline for preprocessor wherein we deployed the column transformer, and then followed once the pre-processing step is over, then we'll go and apply logistic regression. So the pipeline is set. Now what the pipeline does is it calls one function at a time. It will combine all the data set and then it will call the logistic regression. So all that we need to do is simply say pipeline.fit. When I say pipeline.fit, it will iterate for say 2000 number of times. And once the iterations are over, I think we have already reached the limit of iterations. That's why it is throwing this warning. But we can ignore it for now. And the overall score is around 84.8. And this is how the pipeline looks like. You have pipeline. These are the num calls. These are the categorical calls. There's a logistic regression and so on. We can make predictions by doing this clf.predict predictions. And say y underscore val ads is equal to this. So all the predictions are stored here. And if you want to get the probability, even that is possible. Say y underscore val says probability clf dot predict underscore proba followed by a x value. Let us see the confusion matrix. As you can see, though it is doing well on class 0, but it is not catching all the patterns of class 1. Almost half the records are not classified properly. Okay, that is of course because a linear regression is a linear model, right? It cannot apply the classification properly if there is non-linearity in the data. That is what it is trying to show, that there is some non-linearity in the data and it is unable to classify the records. But for now, we'll stick with logistic regression because there is only for understanding purpose how to implement a logistic regression. And I'm going to use a classification report to find out the F1 score, the precision and recall. You can go through all that. And I can also calculate the F1 score. I'm getting like 83.8. It's a weighted average of both precision and recall. This is our ROC curve. The area under curve is around 84%. That's what it says. And then if you want to make a prediction on the test data set, I can simply pass my test data to the pipeline and make the predictions. Okay, this is my prediction from the test data set. Okay, I think that is all for today's session. We just wanted to see how to implement a simple logistic regression model for the classification purpose. Of course, the model is not performing well. We know it is not performing well. We will have to go to a complicated model or find out some other features for now. So as we have a limited data set, I do not have a possibility of increasing the features. I will have to go to a complex model. We will deal with the complex models in coming sessions. Thank you.